just kind of the definition of a polynomial function. I'm always going to put it in we always kind of record a function in a particular order. So I just call it, we always give it a name, whether it's f of x. We don't really call a function y or y equals. That's more kind of a two-variable equation or whatnot. We give a function, we usually give it a name, call it f of x, g of x, h of x, more familiar name. So, f of x, and then everything from there on is, in descending order, I guess this is kind of an example. You want to start with the largest degree polynomial or largest degree monomial, okay? And then each term, it descends by 1 degree. So, for example, well, I guess just kind of put I'm not sure how they use their terminology in here. They have x, or a sub 0, x to the n, and then everything kind of descends from there on. So, so plus, a sub 1, x sub n minus 1. So notice that the degrees are decreasing, and then your coefficients, a sub 0, a sub 1, a sub 2, and again, n minus 2. And that, that goes on and on and on and on and on. You keep going until you have a descending order, and then your constant. That's just the definition or the way that a polynomial function goes. So, for example, we had f of x, to actually put numbers in here. You guys seen these already dealing with trinomials. That's a polynomial. That's considered to be a polynomial function. So, for example, if we had 3x squared minus 5x plus 3, okay? But that's all that we've messed with, okay? In this chapter, in this section, you're going to learn, there's obviously higher degree polynomials that we can deal with. And we want to learn the behavior of their graphs, what their graphs look like. So we already know, we should have a good idea what a quadratic function graphs, what type of graph. So that's what this, function is graph. And then we're gonna, so now our goal should be, let's call this function a different name. Let's call it g of x. Let's go x cubed minus x squared plus 5x minus 2. Descending order from least to greatest, or from the greatest to least. But then we actually call this a cubic function, or a cubic polynomial. This one up here was what? Quadratic. Why do we call it cubic? Well, it's the degree of this polynomial is to the 3rd degree. It's a 3rd degree polynomial is what we call it. Okay, and then you have h of x. Obviously you can keep going as high as you want to go. Now, to be considered to be, say in this case, a 4th degree polynomial, do I have to have all the terms in here? No, I don't. You don't have to have all the terms in here to be considered, a 4th degree polynomial. So I can just have, x to the 4th plus x squared minus 9, and this polynomial is still considered to be a 4th degree polynomial. Okay? And that, even though I don't have all the terms, I'm still missing some terms, but it's still in descending order. The highest degree term in here is the 4th degree, so I consider this to be a 4th degree polynomial. All right. Now, just some terminology that we need to remember is what's the least. Okay. So, and then, the degree of the polynomial, obviously, we kind of discussed that already. So the degree of the polynomial is the term, which term in here has the highest degree? Well, obviously it's the 3x squared term. Therefore, it's a quadratic. Our highest term in this one is the x cubed term. Therefore, it's a cubic. And then I think actually the 4th is quartic. I'm not sure.
Yeah, it's quartic and then
Is is quartic. So Q-U-A-R-T-I-C, quartic. Anything past that's usually just considered the polynomial to a certain degree, I think. So, for example, if we just have, well, let's kind of analyze this one real quick. Let's say that we had f of x equals x squared plus 5x minus 3. I don't even need to graph it, because I should be able to just look at that and notice, know how, first of all, what does it graph? A parabola, a U-shaped graph. How is the parabola going to open? Up or down? It's going to open upward because, it opens upward because the leading coefficient is positive. It's a positive 1, so therefore your U is going to open upward. Well, so let's kind of analyze this real quick. I'm not even sure if this has got any real number solutions. I think it does because it's got to cross -3. So 1, 2, 3. So somewhere in here, something like this. Not sure if that's correct or not, but we'll go with it. So let's just say this is the function of f of x. Okay. Now I want to know what the behaviors of the graph of the endpoints are, the endpoints of the graph. Okay, so as f of x approaches infinity, as x approaches -infinity, what does f of x do? Then f of x approaches what? What am I referring to when I say x? Am I referring to the domain or the range? I'm referring to the domain, and the domain's on the x-axis.
So then your f of x would be how high the.
So as x approaches -infinity, so that means I'm going that way.
So then
what is f of x doing?
Positive.
F of x is approaching positive infinity. Okay. Now as x approaches positive infinity, then f of x does what?
Positive infinity.
Still goes to a positive infinity.
Because it's opening.
Because it's going up. So f of x is coming that way. Alright, now, so obviously this scenario is a good when a is greater than 1, or when a is greater than 0. Now if this situation will be a little different if a was less than 0, right? So obviously then it would be open downward. And then these two values would probably be flip-flopped. Be -infinity, right? It wouldn't be flip-flopped, it would just be the opposite of what they are. Okay? Alright, well, next, I guess, we should kind of have a pretty good idea of that one. Kind of getting the notation down there. Let's do a different one. Let's see here. Let's say we had a cubic polynomial. Let's just go with x. Let's just go with f of x is equal to x cubed. And what I always look at this is a cubic polynomial is. I always kind of refer to it as the disco. You guys ever know what the 60s, grew up in the 60s, and how they used to dance, They used to do the disco dance where they just go, whoo, like that, and they throw their hips into it and everything. Whoo. That's one finger goes up, one finger goes down. So think of a cubic function, or even an odd numbered function. Okay, I'll explain that here in a second, but you have a cubic function that kind of looks like this. Okay, that's pretty close to being the x cubed cubic function right here. Now it could get fatter, narrower, it could get stretched out more, whatnot, if you had obviously more terms in your polynomial. But the pattern, or I don't want to say the pattern, but the gist of a graph for an x cubed or a cubic function looks like an S, just like that. Okay. So then you analyze the graph with this one too. So as x approaches -infinity, then what does f of x do? X approaches what?
Negative.
Negative infinity. If x approaches positive infinity,
Positive.
what does f of x do?
Positive.
Positive infinity.
They're always
Okay.
gonna be the same as
Now, what would happen? What would happen if I were to change the leading coefficient to negative?
It would just be backwards, right?
Huh?
It wouldn't just be backwards.
Yeah, you're somewhat right. Yeah, it'd be kind of backwards. So what would happen is basically it flip flops itself. So in this case, it comes down like right here and goes like this. So the graph in the black here is f of x equals negative x cubed. The graph in the blue is f of x equals x cubed. Alright? And then obviously we'd have to do a little bit more thinking on here. So we got x cubed, or I'm sorry, as x approaches positive, let's go with negative infinity first. Then f of x is doing what?
Going up.
Going up, plus infinity, positive infinity. Same thing, vice versa. If x approaches positive infinity, then f of x is approaching negative infinity. Okay? There's your cubic function. Alright, one more. Has to do with, obviously, fourth degree or quartic polynomial. This, I want you to kind of really pay attention to this. Let's just say we had x to the fourth. And notice the difference between even powered functions and odd powered functions. Let's say we just had x to the fourth here. Let's see if this is going to work. See how does this work. What? Symmetrical? I don't remember how I screwed up that, but this is not the exact f of x equals x to the fourth graph, but it's the right idea. Okay. What do you notice about this graph that's similar or the same as f of x equals x squared?
They both go up.
They both go up, right? So that's something that we can make a note of. Note that even powered functions, have similar or the same end behavior. Okay. Okay. And then obviously the odd powered functions have, if they're the disco thing, when I always do it, when you're doing the disco, they're opposite, one's going to be approaching positive infinity, and the other one's going to be approaching negative infinity, depending on your leading coefficient, whether it's positive or negative. So I guess I'm just going to put here opposite in behaviors. I'm not sure if that's the right way of wording it, but